new webinar about Literal, which is a brand new phenotyping device developed by Arvalis and IFEN during the last few years, which is a handheld device and bringing high throughput phenotyping with high resolution to field trials. So we're going to dive into a few use cases today, and also some technical specs and specifications, of course, of the system. And this will be done by Benoit de Solan, which is a program manager at Arvalis. Hello, Benoit, and also by Alexandra, which is campaign project manager here at IFEN for several years now.
Hello, everyone.
So yeah, welcome again to this webinar. Thank you for joining us, and let's dive into the main topics, so the Literal system. Alexandra?
Yes, I'm very happy to present you today the Literal system, so you can see it here in action. As Nicholas already told you, the Literal system is a handheld system, so, well, like a long selfie stick, I say usually, that's attached to the body of the user. And you can see, well, it's for outdoor field phenotyping. You will see during the presentation for which use cases we recommend it. But yeah, it can be used for many different crops already outside. And I think in the next slide we will see it again. The tablet where everything is centralized. Where you will have like your different plots. You will select your plots, and then you will take very easily one or more images of your plot. And while talking about images, for sure, attached to this stick, you have, yes, one main camera, or well, say let's more two main RGB cameras, but also one near-infrared sensor, and another RGB camera that is in a 45 degree, also fixed to the stick, to have another angle to see your crop from another angle. Well, there are many different data types that can be acquired with this one Literal system, thanks to the different cameras. So you have the 3D images, thanks to the two RGB images that will see, well, the canopy. And then thanks to stereo vision, you can have the 3D map of the plants. Then, well, thanks to the RGB and to the near-infrared sensor, you can have the NDVI of the canopy. And then, well, as I said before, this lateral camera, you will have, as you can see in the image here on the right, another view of the crops, for example, in this case, to really see a lot of details such as diseases. Literal was built, well, mainly for two main uses out of the field. The first one would be, well, we call it scouting. So here you can monitor, for example, your production fields, so big fields with satellites. And then, as you can see here in the image on the left, there are some zones where maybe something is going wrong, because here, well, it's the biomass or the NDVI. You can see that it is less developed than in other parts. And maybe, well, in these areas, you would like to go into the field with the Literal system and acquire some more detailed images to get some information about the crop, to know what is happening here. Are there diseases? Are there, I don't know, many weeds or, well, other stuff? Or, well, the second use that Literal was developed for are small field trials, as you can see in the image on the right. And, well, as we are very close to the vegetation, you can have like the results with very high precision. So you will see it once again during the different use cases that Benoit will present you today, that really we have a great precision, a great quality of the data.
So let's go to some proven use cases to show the power of the tool. So I'm Benoît de Solan. I'm in charge of the development of phenotyping tools and methods for Arvalis. And here are some examples of applications we deployed in our field trial network. The first one concerns plant count, which is often long work to do. The second will be on organ counts for wheathead detection, then disease infection, mixed crop monitoring, and satellite data enrichment. So for the first one, we first focused on flax crop counting. So at early stages, because for flax, the density of plants is very important and it's very high as well. So counting in the field is long. We see on this graph that at the image level, the accuracy is very good. Then when we compare at the plot level, we have a weaker correlation due to the difference in sampling. In fact, with literal, we can sample much more in the microplot than with visual countings. And that's a common finding when we compare digital tools with visual scoring. Usually we have good accuracy, better accuracy from digital tools due to a higher sampling effort. For wheat, we saw that there are some publications. There is also a PhD thesis in a research institute in Hae working on this. So it's not validated at large scale now for our institute, but we will work in the coming years on this crop. So the second use case will be more developed later. It concerns wheathead density estimation in the field. So I will go more in detail after. It's also based on deep learning methods to identify wheatheads. A third use case concerned disease scoring in the field. In this case, it's septoria. The idea was to really focus on the leaves and not on wheat heads or stems. And therefore, we developed a model to only keep vegetation, and in vegetation, focus on the main crop, and in the main crop to select leaves parts, and on this to classify which parts are green, chlorotic or necrotic. And due to this fine discrimination, we are able to calculate a percentage of disease, which is very close to what we can do visually. So from the graph, we can see that we can monitor finely the dynamics of senescence on different cultivars with a good accuracy. And on the lower graph, we see that the yield loss due to symptoms is well explained by our digital literal scoring than with visual scoring. So we develop, and that's also another common findings, is that usually the digital tools are more related with yield losses or yield potential. Next use case concerns mixed crop monitoring, which is something very difficult to assess by traditional means. So in this case, we are in the field of agroecology. We want to design new cropping systems associating different crops. And in this case, we need to classify and quantify the development of the different crops individually. So we developed semantic segmentation algorithms to, in this case, separate the cereal and the fava beans to see the relative development of each species, and also to control, to check if weeds are also where was developed. Another interest of literal in this case was to be able to also monitor the height of each crop. because in the management of this kind of systems, the difference of height between the two crops is very important. If we see that, for instance, the faba beans is becoming higher than the wheat, then we can have some trouble for the main crop, and so we can maybe regulate the growth of this faba species.
Yes, well, I already said it before. Literal was not only well developed for field trials, but also, as you can see here, on big production fields where we can combine, for example, satellite data with drone data, but also with literal data to really, yes, go to the zone of interest where something is going wrong, whatever, well, that can be, and investigate this zone more in detail. And yes, well, here, for example, an example where I think here you have, well, some weeds, for example. So, well, it can be very different. In very different cases, you can use the literal and see what really is going on in that specific zone.
Yes, it can really act as a close-up to specific parts of the field to really understand what's behind the global signal at the satellite level or even at the drone level, where usually we don't have enough resolution to finally detect weeds versus main crop, for instance. So we can we can now make a focus on let's say emblematic use case, which is wheat head counting from high resolution literal system. So for Arvalis, it was a big issue and a strong, yes, a frequent request from our colleagues in the fields. So in Arvalis, we have 27 research stations in France. We wanted to validate at large scale these techniques to replace visual measurements. So we focused on 5 main trials from north to south with a typical design of 30 genotypes, 3 replicates, and quite large microplots. So on these trials, there are, yes, you can go ahead. We have traditional ways of counting, which is visual countings on 2 subplots of 1 by 0.35 square meter. And with literal, we took 6 images of approximately 0.5 by 0.5 square meters. And on one of this subplot, we counted as well the wheat heads to really estimate first at the image level before comparing at the plot level. So if we compare results of literal counting with visual countings at the very precise image level, we see that the RMSC is around 37 heads per square meter on a quite large range of densities from 200 to around 800-900. So a relative root mean square of around 6%. So that's at the single image where we already counted each single wheat head in the same orange box. Now, if we compare the mean value obtained from literal with the mean value obtained by visual countings, we see that the RMSC is twice higher. So it's probably due, again, as for flax plant counting, to the difference of sampling effort during the 2 tools. So we know also that so visual countings is approximately 40 heads per square meter error due to visual errors, etc. So now, if we want to really see which method is the best at the trial level, we can calculate the mean by so the genotypic value, the mean genotypic value for each for the different trials. So each point represents the mean density for a given genotype, and the colors represent the different trials. So we see here that for all the trials, we have a higher heritability at the trial level, which is a good point. And if we go further now, if we put together the different trials to see if the the different classifications of genotypes is the same ranking between the different trials, we see that we have a higher correlation. Oh, if I can point, yes. With literal, so we have a better agreement between different trials with literal than with visual scoring. So these different elements, yes, in conclusion, yes. So we have quite good evidence that the method is reliable and accurate. But another interest of these tools is that we can go further. Using the same images, we can go further. So for instance, our colleagues from INRAE, Raúl Lopez and colleagues, use the same images to estimate not only the number of wheat heads, but also the ear area index by segmenting all the wheat heads. And they found that this indicator, which is obviously related to the hair density, is better related to yield than the wheat head counting, because when you can count small ones, big ones, and the estimation of ear area index provide an additional and valuable information. Another possible extension of this work is also to classify the different wheat heads to see what is their sanitary status. So is there some fusarium, for instance? So there were some early works from colleagues to see if we were able to classify the percentage of wheat heads affected by this disease and provide a global score. So to summarize what we obtained from this work is that obviously image acquisition by literal is much faster. So let's say between 10 to 50 times, depending on how many subplots are taken in the field. At the image level, literal accurately estimates the wheat head density with a relative RMSE of approximately 5%. At the plot level, this error is probably as important as visual countings, probably less, but it's hard to really demonstrate it, due to a better sampling of the plot's heterogeneity. And at the trial scale now, heritability values are higher with literal. And at the network level, the genotypes ranking, is more consistent with literal. And last, there is no obvious bias of the method on genotypes ranking. So this information can be complemented by other traits, such as area and in the near future, the presence of disease. These conclusions, yes, that's really what we found for many applications and use cases. Digital phenotyping usually is faster, at least as accurate, and due to its procedure, provide higher heritability.
Yes, very interesting, all the different use cases. To finish this webinar, well, we would like to also give some, well, workflows. How does it work in practice? So, it's very easy. When you have, the literal at your station, What you need to do first is to draw a plot map. So this you will do it in your office. Then you will load that plot map into the literal system, into the small tablet that we saw before, and you can go out to the field to acquire the images. Then once that is done, so one or maybe more images are linked to each plot that you have drawn before. You need to upload all this data when you are back in your office to Cloverfield. So Cloverfield, that is the data platform, an online data platform from Cloverfield that you can see here. And really, the aim of Cloverfield is for sure to give you back the results. Results that you can download in a CSV file, for example, and then do your own analysis. But Cloverfield is also there to have already a very quick overview of your results. So, for example, you can see different trends, you can compare different modalities or also genotypes, you can see variations over time. And what is also very interesting is that you can go back to the images that were taken on the field. So, for example, some weeks later, you would like to see, how was that plot when I were in the field? So you can go back to Cloverfield and visualize the plot images. To summarize also what we've seen today is that Literal was really made to bridge the gap between the high throughput satellite or drone, image acquisition and then analysis, and the high resolution phenomobile. So phenomobile, that could be, for example, phenomobile, that's what we call it, like a tractor with different sensors attached to it. So in this case, the throughput is very low, but you're very close to the vegetation. And so you have very great images where you can do a lot of things, for example, diseases. But today it's quite expensive. So Literal really wanted to bridge the gap to make accessible one very easy tool, affordable, but with high image resolution, where you can, for example, analyze diseases, wheat head counting, and so on. Just to give you small idea of what the Literal system can do. So it is more designed for smaller field trials, but still you can do up to 150 plots in 1 hour. And as you can see, the battery is designed to last at least for 6 hours. And as the system is not that heavy, and also it is attached to the body of the user, it's really easy to at least do half a day out of the field and get a lot of different results. To summarize, we saw it already, but to have it in one slide here, the Literal system can be very interesting for different markets. So, first for the plant breeders, but also for product developers in more or less small plot trials to filter the best genotypes, for example, or also to test the product efficacy. For CROs, what you can do very soon in Cloverfield is also the ANOVA. And also in technical institutions, field experimentations are very often the case. And with Literal and Cloverfield, you can really do what matters, not go out and take a lot of different measures in the field, but really then focus on the results. And last but not least, different cooperatives or retailers, they can use the Literal system for, as we saw before, doing some scouting in the field and then go to the zone of interest. Today, the Literal system is already it can already do different traits in arable crops. So, for example, in wheat, barley, we can count the heads. We can also estimate the biomass, or we can monitor the canopy development. For other crops like canola, sugar beets, potatoes, we are working on, together with partners like Avalis, to develop more traits. And we think that, well, the literary system will also be very interesting for fruit, vegetables, berries, so all the small fruits on the field, to, for example, count the plants, count the flowers, count the fruits. So all that will be possible very soon. And well, to really summarize this talk today, over the last 5 years, Arvalis, with different partners and institutions all over the world, they developed the system, they tested it, they validated it, as we saw today. And well, today Hyphen stepped into that process to industrialize the literary system. And from next month onwards, the literary system will be on the market. And well, as you saw on the slide before, it is already usable for arable crops. But as we see a huge potential also for other crops, well, we are working on that, and we would be also very interesting in your needs and what you would like to do, what you have in mind. So we would be very happy to talk to you about what we can do together.
All right. Well, thank you very much, Alexandra and Benoit, for the great presentation. Thanks a lot to all of those who stayed connected until the end. Hope you learned a few things or you found something interesting in that webinar. So we're going to head towards the Q&A session, and we're going to take the question by order of asking in the chat. So first question is from Frank, asking about the presentation. So of course, we're going to share the presentation as a PDF. So you're going to receive that as an email in your inbox as soon as tomorrow morning with the webinar replay. So if you want to share it with colleagues or fellow researchers or network, you'd be able to proceed. Then the second question from Nan is, what are CROs? So maybe I can just reply to this one. So CROs are contract research organizations. So basically companies that run field trials for their clients, which develop either seeds or products or input products. So they are basically companies you ask for field trial externalization, if you can say so. And such companies are, for example, Eurofins, Syntec, Altadis, and so on. Tadej, well, thank you for your comment. Very interesting solution. Thanks for that. We have another question from Stefan. Is the device limited or optimized for a particular plot width? So maybe Benoit, you can answer this one.
So it's not no restricted to a specific plot width. So with the system, we can really adjust the height of the measuring head, but also the distance to the operator. So no, it's in our case we used it from, let's say, 1 meter to 3 meter high from the soil, and a distance of, let's say, maybe 60 centimeters up to 1.5. So no, it's quite flexible.
All right, thank you. Next question is from Gabriele. Price for the full service? Thanks. Well, so we can share with you by email the brochure of the product with the price and the traits details and so on. Up to now, for the hardware at Hyphen, we price it around 17,000 euros. But we can have a specific chat for that to know more about your needs and everything else. Next question is from France. Hi, is Cloverfield mandatory to process data, or is it possible to get some data counting directly on the tablet in the field? Maybe Alexandra?
Yes, well, that is a good question. No, well, Cloverfield, it's not mandatory in the sense that if you would like to analyze the images on your own, you can do it. It is designed as well. The images, the raw data is yours. But well, for sure, it's easier to use Cloverfield as the pipeline is already in place. But no, you won't get any results directly on the tablet. You need to link it with Cloverfield to have all the results in the end.
Yeah. However, results can be delivered quite quickly through Cloverfield for what we call the basic traits. So traits that don't need any development, which have already pipelines that work in production. So yeah. Next question from Remy. What will be the use of the near-infrared camera more than NDVI? Benoit, do you want to take this one?
Yes, so for we think that there is an interesting potential for this wavelengths. So it can be used also to retrieve probably chlorophyll content, because in the near infrared there is no chlorophyll absorption in opposite to the red or green bands. And also we know that it can be sensitive to some diseases. So there is still some research to conduct to really have a final product. But yes, it's the main applications are, I would say, chlorophyll and also disease detection.
Yeah. Thank you, Benoit. So I think we answered at the same time question from Amaury about chlorophyll. So yeah, that would be possible.
Yes, we are working this year on this topic. So we will have a quite intensive validation campaign to retrieve this information. But yeah, the interest is to really retrieve it at the pixel level instead of more integrative spectral indices that usually work at the 1 square meter. Here we hope to be able to be more spatially explicit on the mapping of chlorophyll content.
Thank you, Benoit. Dalse asked another question. I already collected photos of plots and ears panicles from wheat breeding trials in Ethiopia. Can you provide access to process my data using chlorophyll? So we can have a follow-up chat about that, Dalse. Would be a pleasure to know more about that, for sure. Thanks for asking. Next question is from Gary. What is the smallest plot size that the system can focus on? For example, early breeding screening trials can use single row from 1 to 3 meters plot or hill plots, small bunches of plants with space between lines.
That's a good question. So this year we had three. So the smallest we processed this year was plots with three lines of wheat, so around 0.5 square meter. Then the issue is really to extract single lines. So it's more on the pre-processing, because with a single image, for instance, you can have 3 to 5 rows. So in a way you can monitor 5 lines at a time, but then you need to really extract each individual line. So it needs a little bit of pre-processing to extract each lines, and then it's possible to extract the main traits at this scale. So then each line will be considered as a microplot in a way.
Thank you, Benoit. Lucas asked, is the wheat head count and plant height accepted by the Federal Variety Office?
Yeah, very good question. Not yet, I would say. But, well, I think it's a very big subject, to also use digital tools for the Federal Variety Office. So I think that we are on a good way to use it. Well, when, I cannot say it, but well, we hope as soon as possible, as it really, it's easier, it's quicker, and also as we saw in the results, very often, well, it's more precise and also more, well, objective compared to manual assessments.
So it's an ongoing process. Thank you, Alexandra. Federico, some thanks. I need to review that PDF. Yeah, for sure. So you're going to receive the PDF in your inbox. Amaury asked, how long do you think it will take to process the images on Cloverfield? Alexandra, do you want to take this one?
Yes, well, not a lot of time. I would say that, well, one day, even less, some hours. It is possible to already have the results.
Yep. Yannick then asked, are there other indices possible or only NDVI?
Yes, so there are all, let's say, all indices based on RGB bands plus near infrared. So we know that, for instance, CI, so chlorophyll index using the green band is also interesting and can be computed from this device. So yes, there are a few other indices that can be calculated.
Thank you, Benoit. Cindy Torres asked, 17,000 is for the hardware or the service? Well, it's for the full package for the launch of the product. But again, we'll have a specific follow-up discussion with you, Cindy, if you don't mind, so we can have a deeper dive into understanding your needs and giving you the price that match your what you really need. Ganesh then asked the question, is the system model for light intensities, height of imaging, and other manual errors? Light intensities, height or imaging, and other manual errors.
Okay. Yes. Okay. So so there is a control of the exposure of the camera of the image, of the cameras of the image. So you can, depending, and actually that's a good question, because when you have quite low crop with less shadows in the crop, it's quite an easy situation. But then when you have a high crop with very strong shadows on the below and very reflective, for instance, with heads on the top, then you need to adapt the exposition and the integration time. And so there are auto exposure programs to prevent overexpositions or underexpositions. So yes, it's quite well controlled automatically. And then for the height, so we actually we calculate afterwards the height of the system for each single image, thanks to the stereo vision system, which allows the calculation of the distance between the camera and each pixel of the image. So we can afterwards check the distance and the height of measurements.
I think in the tablet you have several, parameters that indicate you if you're.
Yes, you also have an inclinometer which allows you to control the planity or the horizontality of your acquisitions. You can even really prevent acquisitions if it's not in a given range of angles.
I think very hard to acquire bad images.
That's what we try.
Yeah. Thanks. Yannick asked how long to get results from your bugs. So I guess we answered that one too. So within a day, for most production traits, you can have results available on Cloverfield, so on our data platform. Next question from Mosen. What are the limitations of the literal unit for scanning a field with taller crops like sugarcane? Is stalk count, population, and stalk length measurement possible? That's actually a good question. Definitely Hyphen has experience on sugarcane with drones, but with literal, no test has been conducted on that crop. So we probably need to learn a bit more about that. But Benoit, have you got experience with taller crops?
We have experience with corn, yes. So at 2 stages. So at early stages, obviously up to 1.5 meter, let's say. it's well adapted to take images from the top, and it's possible from this to retrieve the green cover fraction, the crop height, also if there are weeds, weeds infestation, for instance. Then, if you want to estimate the leaf array index, for instance, we usually take images from below and looking upward. So it's a big, it's a change in the configuration, but it's usable only this way. But obviously, for this kind of very tall crops, drone is very valuable also.
Thank you, Benoit. Lucas has another question. What does the plot map look like? Do you need just an Excel or CSV list for your plots, or do you need to design a georeference plot map with GIS?
Yes, that is also a good question. So, well, when using the literary system, you will get access to a tool, a Hyphen tool, where you can, well, draw your plot map, draw your plot map on your own. So you don't need a referenced plot map. You just can input like a CSV file, for example, and then we'll see on the display in the tool where the different plots are and with their names. So, well, we wanted to do it as easy as possible for you.
Yeah. And you have also a feature included that tells you near which plot you are, so you can start acquisition on that plot using the GPS.
Yes, there is a
GPS
in the system. And so the basic format is GeoJSON, but yes, there is a tool to generate it from quite simple information on the crop, on the trial design. So number of rows, number of lines, and then you can then, yes, generate your plot map.
Yeah. Thank you. Yannick, can this be used in a greenhouse or small plant pots? Well, yeah, we hope so at some point. For sure, it will fit in a greenhouse. But yeah, then it's depending on the use case, I'd say. Do you want to add anything?
No, I think in the theory, yes, that would be a third use case that we would like to add. Yes, definitely.
Samuele, what's the way to perform radiometric calibration and stereo vision related calibrations?
Yes, that's a good question. So for radiometric calibration, we propose to use a gray panel before acquisitions, with allow to make, let's say, a white balance for the different channels, RGB plus near infrared. So that's the way, because we calculate the coefficients for each wavelength. And for the stereo vision, so there is already calibration which is calculated for each individual system, and which is provided with the system. So it's information which is embedded in the system and which allows to reconstruct the distance map and so the height map.
Yeah, thanks, Benoit. Cindy Torres asked, are you considering selling the hardware without the service? If so, do you have a price? Well, again, Cindy, thanks for asking. Really appreciate your questions. We may want to have a specific follow-up to really understand your need and tailor a specific proposal for you, I'd say. Thanks again for asking. Gary, in the mixed species example, faba, wheat, and weed data was shown, possibly by differentiating between broadleaf grass and plants between rows. Can the system differentiate between multiple species of broadleaf crops, example rapeseed and peas, intercrops?
Mm-hmm. So in fact, we know that actually we designed the system to be able to have images allowing this kind of segmentation. Now that there are probably, well, at least for Arvalis, we worked for our crop of interest, so mostly cereals and some associated crops like fava, alfalfa, peas, lentils. And then for and we try also to mutualize this data set with other partners from various foreign partners and French ones as well. And so that's possible to develop new models from these images and to implement these segmentation techniques for also probably rapeseed and peas and intercrop.
Yeah, absolutely. I mean, the high resolution of the camera, the different viewing angles, and also the proximity with the canopy, as it's a handheld system, allows to acquire really good quality data that can be used to train new models to detect things that we want to detect and make it a production trail at some point for future campaigns. So the beauty of that tool is really to access really high resolution traits and images to extract information from them and learn things that you cannot learn with a human eye, as we can see in the small graph on the table here. It's really giving you access to things that may be hard to assess at some point.
Maybe another point to add is an interest of the system is to standardize also the kind of images, and in fact it facilitates the development of new models, because all your images in your trial will have the same characteristics, the same resolutions, the same colorimetric balance. So as all acquisition parameters are controlled, then the development of new segmentation models, for instance, is much faster than if you get images from many systems, from many different smartphones with different white balance, etc.
Yeah, right.
That's an interest of the system, I think.
Absolutely.
And also to share data sets between institutes or between partners. It's also easier because it's the same data format. And in this specific data format, all information are recorded. So the GPS information, inclination, design, etc. So
yes. There's good traceability of each image took with literal, and the beauty of Solve that is that it's for you, it would be always simple to acquire those images because everything will happen in the background. Don't have anything to set up to get those good quality and good traceability of images. Still just click the screen and you get your data stored. All right, Yogesh, advantages of literal of flying a drone closer to the canopy. Well, that's a good question too, but you can fly a drone closer to the canopy, but there's a few challenges that comes into the equation for that too. So, Alexandra, do you want to say
from
something?
our experience, well, yes, sometimes it is possible to fly very well close to the vegetation. Sometimes it's a challenge because there are some like security things on the drone that doesn't allow you to go very close to the vegetation. And also, for example, well, if you want to detect weed heads, that the drone is making some wind, and so, well, if you're very close to the vegetation, the whole image will be, well, blurred because of the wind of the drone, and, well, finally you cannot detect anything. And, well, then also the drone doesn't have the 45-degree camera. Well, I think in theory you could maybe, well, fly the drone in a different way to get this information too. But, well, the advantage of the lidar system is to have, well, both drones and both cameras in the nadir view and the 45-degree angle to just see the crop from different views. And then, for example, for disease detection, it's much easier to not only see the canopy but also see like into the canopy a little bit.
Yeah, thanks, Alexandra. Of course, it all comes down to the use case that you have or to what you want to assess.
Exactly.
Then we can trigger acquiring data with specific signals, so specific sensors. The beauty of Literal is that it combines multiple of those sensors, plus different viewing angles, plus really strong protocol to make sure that the data would be consistent and qualitative. So in the process, it's easier than a drone, so you don't have to place GCPs in your field to record the coordinates, and the processing is also faster with a literal than a drone. So both are valuable. It all depends on the use case and what you want to measure in the end. But thanks for asking, actually, it's a good question. Amaury asked another question: what is the weight of the complete device? Important information for our technicians. Well, of course, it was something that all the team kept in mind developing the system. It has to be portable. It has to be usable for a day of field activities by the technicians. So as we mentioned in the slides above, I guess the weight of the system is averaging 6 kilograms in its industrial version. And yeah, I'd say that the team has spent a lot of time improving that and making sure it would be the most easy and handful as possible for the technicians in the field. And well, we'd be happy to give you a demo of it at some point and maybe have one at your station so you can try it and give us some feedback on it. Guillaume Lefranc asked a question. There are already a good bunch of tools DSS to estimate nutritional status of the crop, but is lateral could bring something to estimate the plant nutritional status or need of specific nutrients, fertilizer. Yeah, Benoit?
Maybe, yes, I would say it's not specific. I think the interest of literal is that it's not only an estimation of nutritional status of the crop. It's a full description of the development of the crop. So at the same time, you can estimate crop height, crop leaf area index, the presence of senescence, etc. So it's more a full checkup of the crop at a date. So yes, that's what I would say compared with only a measurement of the chlorophyll or only a measurement of the reflectance. We have a full description, yes, of the status of the crop.
Thank you, Benoit. Lucas, how many pictures do you need to take per plot to achieve the best balance between high accuracy for simple traits and high throughput of 150 plots per hour?
I think you have, well, for one plot of, I don't know, what is
10
the length?
meters.
10 meters.
Yes, so we work on quite large macro plots, 10 meters long. So we take 6 images, which is a high level of sampling.
Yeah. I would say that it's related to the traits that you want to access. So, for example, weed head density or weed head counting needs a high sampling rate. So, of course, you're going to take more images per plot. If you want to have an estimation of the grain fraction or the biovolume, like something that would need less sampling intensity, I'd say you can only take 2 or 3 pictures per plot, and you would be good with some good precision too. So in the end, it comes down to the traits and the size of your plots, and it's really the reason why we always ask and encourage you to have meetings or specific follow-up with us, because we really need to understand your needs to be able to tailor the proposition that will fit your project specificities. So if you have any interest in that, you can reply to us to the email that will be sent with the PDF of the presentation tomorrow. I would be pleased to have such discussion with you guys.
Then yes, the time for taking one additional picture is maybe not that long. I would say it's about, let's say, 10 seconds. So the longest is to move, then to press the button, move to the next one.
Yep.
take an image is a fast action.
For sure. Yeah. Is there a limitation to the data upload to Cloverfield? That's a question from Lucas again. So I would say no, but it depends on the trial that you had, because most of the time you want to upload data for the entire trial that you assessed. So I would say no, but that's a good question too.
No, yeah. And normally we know in advance how much data you will upload. So, well, no, there are no limits.
Sarah, with regard to foliar diseases on wheat, what kind of data do you get? Chlorosis, necrosis? Can you discriminate between the foliar diseases such as stem spot and septoria? Also, what is the recommended height in order to have accurate data on diseases?
So to be honest, so we have different segmentation models now. So we have a generic segmentation models which allows us to identify which are crops and which parts are soil or residues on the soil. Another model allows us to in some cases, so for some specific crops like wheat, potatoes, flax, to distinguish the crop from the weeds. Then we can, in these crops, differentiate the green parts, chlorotic parts, and necrotic parts. So that's a colorimetric model, which allows us to estimate what we see here. In this case, it's green, chlorotic, and necrotic part. But on really identification of symptoms, we did not integrate yet identification of the symptoms. So we quantify the symptoms, but we do not affect them to a specific disease. So again, we know that with the resolution we can get, if we are quite close from the vegetation, we know that we can have a resolution of, let's say, around 0.2 millimeter. And with this resolution, you can have a lot of information on some patterns. So not all disease, but for some well-known disease, it will be achievable. So the height, I would say, if you really want to have a good description like here, you will be around, I would say, 1.5 meter above the top of the canopy.
On wheat, yeah.
On wheat, yeah.
All right, thanks, Benoit. Hope that helps you, Sarah, understanding a bit more what is achievable with the tool. Volker asked, at which time of the day do you have to take the pictures?
I would recommend when the sun is high, because you have more light in the vegetation. If you go very early, then you will have big shadows, and the bottom of the canopy will be very dark. So I would recommend around midday.
Yep, and good to know that for every little order, we provide you with protocols for acquisition to recommend the best timings for all the traits that you want to access, same as the drone, for instance. Cindy, I understood that there were no results on the tablet, but is there any feedback like plot contour, label recognition, etc.? So the answer is no.
Yes and no, I would say, because you can see the picture that you are taking. So you already see if you really taking your plot or the soil next to the plot.
Yeah,
so
sure.
that is a first, indication of the quality. And also, as we said before, there are some indications of the angle of the literal system and so on and so on. So at least to make very high resolution and good image quality possible. Then yes, more detailed really results that will be then available via Cloverfield.
Yeah, absolutely. So basically no specific feedback except that you have the image that was just took live when you just trigger the acquisition. But then as soon as you upload things on Cloverfield for data processing, we run like quality checks and give you instant feedback on the quality of the data too. So as Alexandra said, it all happens in Cloverfield, not directly on the tablet. Is there or will there be a possibility to use, for example, barcoded plots labeled to automatically navigate to the right plot in the system software, or does the system depend on the plot map?
Yes.
So yeah, that's a good perspective. I would say it relies on the plot map today, but in the future, new improvements and dates can be possible, I'd say. So
definitely.
Yeah, let's see what the future holds. Can we train our own prediction models with combination observed visual data and literal data? That's a good question, maybe for you.
So well, actually, the data format of the literal images is well documented. So it's HDF5 format, which combines all images and metadata in a single container for each microplot. So from this, you can develop all the models you want, all your own processing chain. So that's what we did at Arvalis. But yes, so I would say data format is well documented, and so there is no restriction to develop your own model, but maybe also through Cloverfield as well. I don't know if it's possible to upload models.
So right up to now, no. But again, maybe in the future, we never know. But standardized data acquisition and data storage too. So you can use if you want to internalize trade processing, you would be able to use that data to straight after acquisition. All right. So I think we covered most questions. We had a quite huge Q&A session, lasted for almost 40 minutes. Thanks a lot for staying till the end and asking us a lot of great questions about literal. I think we're going to end it here for today. Again, you will receive the replay of the webinar within a video format alongside with the PDF of the presentation in your inbox as soon as tomorrow. Feel free to share it again, and for those who are interested to know more about the tool and price and trades and all that, feel free to drop us an email or a note, and we'd love to have a specific follow-up conversation to know more about your needs and provide you with everything you need. Thank you, everybody, and thank you, Benoit, thank you, Alexandra, and well, until next time, stay safe, and see you next time.
Thank you.
See you, goodbye.
Bye.